Okay, let's proceed to the next one. Question number 15. It says find the values of the unknowns k, b, and t if the differential equation given by this is exact. So, dear students, what is asked here is just to determine the values of the unknowns provided that the given differential equation is exact, or in another way, for this differential equation to be exact, what should be the values of k, b, and t, the constant values. Actually, k, b, and t are real numbers, okay? So let's see how we can solve such kind of question, okay? So the idea is like this. You need to now consider your m and n as follow. Basically, this is not written in terms of m dx plus n dy equals 0, but using simple mathematical operation, we can automatically change this to m dx plus n dy form. Let you multiple, this is the entire equation of this one by students dx. If you multiple the whole by dx, this dx directly goes to this expression. Because if you multiply the whole by dx, this dx will be cancelled by what the one you are multiplying, and this dx comes, you see, to these two terms. So as a common, you can have 1 dx, and this goes to 0. So your m is going to be 7b x to the power of 4 y to the power of t plus 3, because as we done before, m is nothing but it is the coefficient of dx. So the coefficient of dx is 7b x to the power of 4 y to the power of t plus 3. What about your n, students? Your n is nothing but it is a coefficient of dy. So clearly the coefficient of dy is this one, x to the power of k y cubed minus 5. So n is obtained to be this. Now you have been told that the given differential equation is exact. So if it is exact, according to, you see, the one we raised before, the partial derivative of m with respect to y, that is to say, the partial derivative of this one with respect to y must agree with the partial derivative of n with respect to x. Hence, my must agree with nx. Because of this, the partial derivative of m with respect to y now is obtained to be this one. Look, we are derivating this with respect to y. We don't need to do anything here on 7b x to the power of 4, something like that. The expression is, you see here, our interest is to carry out the partial derivative of m with respect to y. So we need to look for where y is. Here it is. So this has to be derivated. When we derivate this t comes down, and we deduct 1 from the exponent, right? So 7p x to the power of 4 y t times y to the power of t minus 1 can come. Since this one is a 1 without having y, it will be 0. Now let's again perform the partial derivative of n with respect to x. And this will be the partial derivative of n with respect to x is going to be, now look here, x to the power of ky cubed minus 5. So this k comes down and it will be like this. The partial derivative of n with respect to x is going to be k comes down and k times x to the power of k minus 1 y cubed. Since this one is constant, it will be 0. Now my is the same as nx. If my is the same as nx, it will be what? Exact. So let's equate the two. Since we have been told that the given differential equation is exact, my is the same as nx. So my is the same as nx implied that, look, for these two to be the same, the k minus 1, which is the exponent for x, must agree with 4, as you see here. So if k minus 1 has to be 4, we can know what k is, you see. And here the coefficient of, the exponent of what y is t minus 1. Whereas the exponent of y is again 3 here. So necessarily the exponent of t minus 1 must match with 3. So t minus 1 is equal to 3, and from this t comes to be what? 4. So we are having now t to be 4. And again, if you observe, as I said before, the exponent for x is k minus 1, and here the exponent for x is again 4. So x minus 1, k minus 1 has to be 4, and from this one can determine k to be 5. Now what is unknown? The only unknown left over is here 7b to be k. All right, 7b to bk. So 7b, we do have t in between two. 7bt is equal to k. We knew what k and t are, so put the values here. In place of t, have 4, and in place of k, let you take 5. So 7 times 4 makes 25. So this makes what, students? 25. 5 over 25. So the value of b is now determined. So everything is determined. So in such a way, we can determine the unknowns. And proceeding to the next one, we have the 16th question. It says, form an exact differential equation from the function f of xy is equal to e is a power of xy sine xy is equal to c for some constant number c. As long as this one is continuously differentiable, students, we can formulate, you see, or we can construct an exact differential equation from a continuously differentiable function like this. What we need to do is we just need to perform complete derivative of this function. You studied how you can find complete derivative of this function of two variables in applied 2. So let's apply complete derivative of this one. But before that, you need to know is about the complete derivative of a function. The complete derivative of a function is defined to be like this. Look, the complete derivative of a function of two variables is the partial derivative of the function with respect to x times dx plus the partial derivative of f with respect to y of dy. Here our f is having variables x and y, so we need to perform partial derivative with respect to x, again with respect to y. That's why I told you that your f must behave continuous partial derivative for the given within a given region. So how are you going to determine now the partial derivative of f with respect to x and respect to y? You are given here the function is a power of xy sine xy. So look, students, when we perform partial derivative of f with respect to x, need to derive this one with respect to x, treating y as a constant. But look, as one multiplier, x is here, is a power of xy. You see, in another multiplier, sine of xy, we do have also another x. So x is appearing in both what? Expressions. So we need to undergo product rule for this. And for this to come, look, what we need to do is this. The partial derivative of e is a power of xy. With respect to x comes to be e is a power of xy as it is. But now we need to derive the exponent. When we derive the exponent, y comes down and y is a power of xy, and here sine of xy is taken as it is because of product rule, product rule technique. Then we do have plus in between. Then it's what's turn to be integrated to be derivated. It's what sine xy's turn to be derivated. So you need to take e is a power of xy as it is. But as you are performing derivative of sine of xy, derivative of sine makes cos. So xy comes as it is. But we need to again derive the inner one using chain rule. We need to derive the inner one xy with respect to x. So y comes down out. So y is a power of xy cosine of xy, and then dx follows here. Then you do have plus because of this one. Now next turn is to carry out the partial derivative of f with respect to y, and for that again you need to undergo product rule because y is appearing here in these two expressions is a power of xy and sine of xy, where the expressions are multiple together. So we need to use product rule for this. So the derivative of this one is a power of xy as you see, but when you just do the derivative of the exponent with respect to y, x comes down. So as can you see, x times e is a power of xy can come, and here according to product rule, sine of xy is directly written as can be shown. Sine of xy follows, then plus follows, then you will take e is a power of xy as it is. Now it is this expression's turn to be derivated with respect to y. So as you all know, derivative of sine is cosine, so cosine is here, and then inside the inner inside the bracket we are having xy, so you will have xy as it is, and the inner one, which actually is x times y, has to be derivated with respect to y. So when you derive the inner one with respect to y, x comes out, and then x is a power of xy times cosine of xy is going to follow. So as you see, everything is written here. So this is nothing but it is a complete derivative of what? The function having two variables x and y. So dear students, what can you understand from this? Look, this is a constant one. So as you are applying derivative, complete derivative here, the derivative of this goes to 0. So you can assign 0 here. So one can have the following one. The exact differential equation can be given by, as can be shown here, this expression: y times e to the power of xy sine of xy plus y e to the power of xy cos xy dx plus x e to the power of xy sine xy plus x e to the power of xy cos xy dy equals 0. So this basically is an exact differential equation. Simply perform the partial derivative of this one with respect to y and the partial derivative of this, considering this one as n with respect to x. You will obtain finally that the partial derivative of this with respect to y to be identical with the partial derivative of the second expression with respect to x. That is to say, y will be obtained to be the same as nx. So this shows you that this differential equation is exact.